Western Michigan University. Are you ready?
Sure are.
You may begin.
Good afternoon. We are here to represent the Western Michigan University Concrete Canoe Team in our entry to Iron Bronco. The engineers that led the movement west with innovations in railroads, mining, and logging were this year's inspiration for the team. This theme reflects Western's initiative of encouraging its students to embrace challenges and discover new solutions for the future. By honoring these pioneers, we were able to achieve our lightest boat ever, weighing in at only 176 pounds. We are proud to present to you the Iron Bronco. To start this year, our project management efforts led by team leadership were vital due to a majority of new membership. We utilized our resources and interviewed the past 3 years' captains to develop a list of our strengths, weaknesses, opportunities, and threats, or a SWOT analysis. This SWOT analysis allowed us to better plan and organize our efforts in order to accomplish goals for both this year and years to come. This tool aided in determining our critical path of tasks for the year, which ultimately led to a decrease by 11% in total man-hours spent on design and fabrication, all while being able to pass on knowledge to new members by having experienced members as officers for main concentration areas. The process of design started with the mix shortly after the rules were released.
The mix design team came together and determined 4 main goals: improving the unit weight, workability, fluxural strength, and quality control. The team used last year's mix, Pure Michigan, as a baseline. We increased the cement to cementitious material to 80%, but STU testing yielded a higher compression strength. Through research, we found different types of aggregates that were stronger and lighter than the previous ones used. By adjusting our aggregates, we were able to create a mix at 58.6 pounds per cubic foot. We then made adjustments to the mix design to increase our fluxural strength and our workability by increasing our weight to latex ratio by 5%. By increasing our latex, we were able to increase our fluxural strength and workability despite our 3/8-inch slump. While mix design was being performed, the design and analysis of Iron Bronco was being conducted.
The hull design of Iron Bronco used Pure Michigan as a model to make adjustments. By increasing the width and depth, we were able to increase stability. By decreasing the front rocker, tracking was increased to help with issues encountered when paddling last year. The major change to structural analysis was the idea of using a holistic approach. This reflects back to our introductory classes that set up the fundamentals used in basic engineering. By using this approach, we were able to model the basic deflections and shear moment forces applied by a 2-person load case acting on a simply supported beam that represented the canoe. Through non-holistic approaches, we were able to model or confirm the results. Through intuitive knowledge from our introductory classes, the rib design was created to counter torsional forces that were applied to the canoe by 2 people paddling on opposite sides of the canoe. The fabrication began after the final design phase.
This year, the canoe team had many constructability breakthroughs. The screed rail technique was used for to ensure a uniform hull thickness, which was found as a weakness through our SWOT analysis. By utilizing an assembly line format during casting day sequence, it allowed for the 20 canoe member team to perform 32 rolls. This allowed us to hit an 84-minute casting time to stay within the ASTM C94 90-minute mark. Biodiesel was used as our sustainable release agent for the mold. This particular biodiesel was manufactured at Western Michigan University's biodiesel facility. Using this innovative product, it allowed for us to have a reduction of 65% in total man-hours needed to separate the canoe from the mold. By mixing outside this year, it allowed for the mixed materials to be chilled at a 42-degree Fahrenheit temperature and have a finished trough line temperature of 52 degrees. This decrease in temperature increased the time allotment for concrete placement and finishing without tearing the crystalline structures as concrete bonds begin to form. This also allowed us to extend the dormancy stage in the hydration process of the mix.
Overall, the Iron Bronco represents the history of Western Michigan University concrete canoe teams throughout the years due to the improvements from our SWOT analysis. This year, we were able to create a lighter mix from last year's Pure Michigan. We improved on our quality control with the screed rail method. We were able to build on our signature rib design to include the torsional forces created by paddlers. And we were also able to keep our products local and sustainable by using the biodiesel as a release agent manufactured at WMU. We'd like to thank the judges for their time this weekend, thank Tech for hosting, and thank State for helping us last night. We will now open the floor to any questions.
You mentioned you had a wire screed to control your mix. Could you describe a little bit more about that? And how did you come up with that? And how did you know it would work?
We use the screed rail technique. It basics of how we use it is we use a 16 gauge wire, which is an 1/8 inch thick, and they're placed at 6-inch intervals, which is just short of a troweling. And we place it on the mold, and we trowel our first layer, and we're able to detach it, trowel back over, and then shift it over 4 inches and reattach and reapply our second layer to ensure our uniform hole thickness. And this was found, hole thickness was found as an opportunity to our spot analysis.
And then did you do measurements after you were done, your overall hull thickness, your actual versus your design, and how accurate did that system end up being?
We used many casting day sequences, practices, and we were able to do small sections and measure it that way to ensure our quality control upon casting day.
Your freeboard this year, compared to last year, I guess, what do you think the difference is going to be there? What is your freeboard this year?
Can you restate the question?
What is your freeboard going to be on the maximum load this year? How far is it between the water and the edge of your boat when you're all in it? Are you going to fill it up again this year? I'm sorry, I'll just be direct.
We assumed roughly about 5 inches just based off our loads and the hydrostatic pressure on the beam to the holistic purpose.
Do you remember what your freeboard was last year, or what you had calculated it to be last year?
We approximated to be about 4 inches last year.
What were the elements of your critical path? How did you manage your schedule slippage versus that path?
We created our critical path method by using the previous year's captains, using their experiences to decide our main events that we needed to hit in time to make it to competition on time. And we had officers meetings every Sundays to catch up and make sure that we could adjust for any delays or unexpected errors.
Where did this SWAT method come from? Did you guys hear about that?
At Western, we have both civil and construction engineers in our department, and the construction students actually take some more business classes, so it's one of the approaches that they learned in their courses.
In terms of mixed design, did you have any variations in your aggregates that improved over past when you used Pure Michigan as a base? Is there anything you improved upon from that mixed design?
Last year we used K1 3M bubbles, and this year we found different kinds. So we used K20, K37. It allowed us to have finer aggregates, or finer grade, and they're also round, so it allowed us to have a more listed mix.
What did that do to your unit weight?
They actually were lighter than previous ones used, and it decreased it by about a pound per cubic foot.
Since you use fiber in your mix, what is the benefit of that, and what issues did you get with using fiber?
The benefits of a fiber were also, it allowed us to have a higher compressive strength and fluxural strength. And workability, we decreased it from last year, and we didn't find it that hard to work with it this year, but I had to decrease it a bit.
You got 3 different kinds of cementitious materials, or I guess Portland being one, then you had fly ash, Class C, and then silicon. Did you consider varying your cementitious materials? You got a ratio of like 83 pounds on the fly ash versus like 21 pounds for the silicon. What led you to decide on that, and what would you consider varying that to get any specific properties?
Through testing from previous years and using SWOT analysis, we determined that the silica fume and fly ash that we have used in the past met our needs for compressor strengths, and so we decided to stick with it.
Did you do any tests on any other finer material thermometers, stuff with those?
In terms of cementitious materials or
Yeah.
no, just we stuck with those.
So So if you cast at a fairly low temperature, what do you think the disadvantages are of casting the concrete at 41 degrees versus casting at normal temperature? What do you think the advantages were? Would you do that again?
The disadvantages we found, we had to wait a while for it to start to cure up so we could do a finishing draw. But the advantages was we were allowed a longer time allotment to place the concrete.
Would you do that again?
Yes, we did.
In terms of your display and some of your other products, do you have a special booth that's just dedicated to your aesthetics and your displays, or do you all pitch in and brainstorm that? What is the process to go from the beginning of the school year to finish product now in terms of theme and design and artwork and stuff?
To start this year, we had come up with a list of about 10 different theme ideas, and we wanted to make sure that the themes we had, we could build upon. So we had, after people suggested a theme idea, we came back and decided if we could implement that into a whole design and display. And throughout the year, Western has also created a new initiative through their marketing program for the Still Westing campaign. So we felt that Engineering the West kind of reflected that also, and that we could incorporate it, and it was a good positive enforcement for our students.
We also had different, at the beginning of the year through SWOT analysis, we had specified leaderships for each group, and underneath them we had freshmen who were assigned to each area that helped out with those specific different areas to make the final product.
What did you do to recruit and attract for this year's team to help ensure the sustainability of the selection program in 2, 3, 4 years?
This is a big focus for us this year. We want to kind of bridge the learning curve between any seniors that are graduating and keeping retainment with our members. So we attended many events at the beginning of the year. We have a big event with all the registered student organizations at the university, and then also just for the engineering campus. So we made sure that our display from last year was up there, and that we actually had hands-on activities for our students that were at orientation to do, so that they were interested and wanted to get involved.
You have mixed concrete?
We just did the basic like sand type one, but it was enough for them.
Great. Thank you very much, Western.